Hello everyone. In this video we are going to discuss the topic inheritance of two genes from the lesson Principle of Inheritance and Variation from class 12. So here this is the video of an offline class which is recorded meant for the students who cannot attend the class due to the pandemic, so that they can see and learn the topic.
So today we are going to discuss about the inheritance of two genes, and to explain this, this has been put forward by Mendel in his dihybrid cross. Okay. So the Mendel's dihybrid cross gave us the law of independent assortment. So Mendel's dihybrid cross we will understand here as here two pair of contrasting characteristics. So two pair of contrasting characteristics considered here, that is in terms of the seed color, number one seed color, and secondly the seed shape. Right? As previously in Mendel's monohybrid cross, we have seen that he has taken only one pair of contrasting character, that is about its height, where a tall and a short wing length were crossed, and the results came in the ratio of 3:1. But here we will see what result we get from Mendel's dihybrid cross, by which he has given us the law of independent assortment, which shows or which tell us about the various mechanism or various features by which two genes are inherited simultaneously. So in your syllabus it is mentioned as inheritance of two genes, which we will consider the law of independent assortment and the dihybrid cross by Mendel. So as here for this cross, Mendel has taken two distinct characters about the seed color and the seed shape. So the seed color, the pair of contrasting character is color yellow and green, and the seed shape as round and wrinkled. So here the color yellow is dominant over color green here, and the color round is dominant over color, round shape is dominant over the wrinkled shape. Now here let us try to do the cross and what possible results we get out of this. And as Mendel used the Punnett square diagram to explain this, how the various genotypes can be expressed with the help of a cross. So in this Punnett square diagram, where there are four different squares, right? Okay. So here for parental generation, as Mendel started with a pure line cross, right? So parent will be in its homozygous form. So for round color, as round color was dominant, capital R, and the color yellow was dominant. So capital Y. So this seed will be the seed of round shape and yellow in color. Am I right? So this will be the shape, the phenotypic feature, yellow color and brown. But genotype we cannot see. But as Mendel has done his experiment in a pure line breed, he has chosen the pure line breed. So for that reason, we know that the parents are in this homozygous condition, and as round color is dominant over the yellow, so it's homozygous round and yellow. When it is crossed with the opposite of round is wrinkle. So for wrinkle, small r, and for ring, small y, as the recessive trait is taken in small letter. So this is what will be the phenotypic character of this? It will be the P. So it's wrinkled and green. So round and yellow, wrinkled and green. So this is the parental generation. Now let us see what will be the possible gametes that they will form. What will be the possible gametes that they can form? So as Mendel's law of segregation said that they separate during gamete formation. So as they are in homozygous condition, so their gamete will be same. Capital R means when they separate it will be capital R only. So each of the parent will produce. So this parent will be called capital R. Out of the two, same it will be. So I will write only one. So capital R, and from the color yellow it will be capital Y. When crossed, and these parent will, as it is homozygous, will give the same. So it will be small r, small y. So what we get in the F1 generation? In the F1 generation we get capital R, small r, capital Y, small y. Right? So it is a heterozygous round and yellow. Now you tell me what will be the shape and color of the seed here?
This one will be round
And
yellow.
Yellow, very good. So it will be round and yellow like this. It will be round and yellow as it is the dominant trait. But what is the genotype here? As genotype we can see each of the parent will give the gamete as capital R, capital Y, small r, small y. So when they cross we get capital R, small r. This is for roundness. Whereas capital Y, small y, this is for the yellow color, being yellow as a dominant trait. So it will be round and yellow, but heterozygous condition. This is your F1 generation. Now for the F2 generation, what did Mendel do? For F2 generation, for F1 generation, Mendel crossed between two homozygous dominant and recessive parent, right? And for F1 generation, for F2 generation, the F1 progeny are self-crossed. So whatever result we get in the F1, they are self-crossed. Self-crossed. Right? It means the F1 parent will be self-crossed. It means what? Capital R, small r, capital Y, small y. This is one of the parent. And capital R, small r, capital Y, small y. This will be the second parent. Yes or no? By self-crossing they are same. So this will be the F2 parent. F1 parent for the F2 generation. F2 generation we have not received yet. This is the cross. So what gametes they will give? What gametes they will give? The possible gamete from the F1 progeny, what they will give? They can give capital R, capital Y, right? They can give capital R, small y, or they can give small r, capital Y, or small r, small y. These are the four possible gamete combination that they can give. Each of the parent, right? Eight parent. One parent may give, means out of R, capital R, small r, here capital R is given and capital Y. Then capital R or capital small y it can be. Then small r, capital Y it can be, and small r, small y. So these are the possible gamete of each parent of F1 generation. As parent of F1 generation are self-crossed, so the next parent or the second parent also will give the same gamete. So the gamete we will write on the either side of this one square diagram. So here suppose this is parent 1, this side is parent 1 and this side is parent 2. Right? So here I will write down the gamete, that is capital R, capital Y, capital R, small y, small r, capital Y, or small r, small y. This is 1, and capital R, small y, capital Y, small y, then small r, capital Y, small r, small y. So don't get confused. Be very specific. Specific means how it has come, how you put. Don't by heart it. If you by heart, you will do the mistake. Right? If one in monohybrid cross only about the height, that is whether tall or short, are crossed and what are the possible progenies obtained. So that is only the difference, and the rules or the steps or system is same. So as I mentioned that in Mendel's monohybrid cross, one pair of characters is considered, here two pairs are considered. So and the rest is same. I mean about its steps or the procedure is same. So we will see now what are the possible result we are likely to get with this cross. So what after the cross, what genotype we will obtain here? This will be round and yellow, right? So round, capital R, capital R, capital Y, capital Y. So all the round and yellow I will write with yellow color. So round and yellow, and this will be also round and capital R, capital R, capital Y, small y. This is round and yellow. Then this one is also capital R, small r, capital Y, capital Y. Capital R, small r, capital Y. So these are all round and yellow. Then this will be round and green. So round and green I will write with green color. Round and capital Y, small y. This one capital R, small y, small y. Round and green. This one also capital R, small r, capital Y. This one is round and yellow, right? Capital R.
First one also round.
Round and yellow. Okay, this one also round and yellow. So I will write capital R, capital Y, small y, round and yellow. And this one capital R, capital round and green. So with green color, capital R, small y, small y, round and green. Now what would be this? R, capital R, small r, this will be round and yellow. Capital R, small r, capital Y, round and yellow. And here capital R, small r, capital Y, small y, right? This one is also round and yellow. And this one is small r, wrinkle and yellow. So for wrinkle and yellow, let me write it blue. Small r, capital Y, wrinkle and yellow. And this one also small r, capital Y, small y, wrinkle and yellow. And here round and capital R, small r, round and yellow. Capital R, small r, capital Y, small y, round and yellow. And this one capital R, small r, round and green. So round and green, what color we gave? Pink, right? Capital R, small y, small y. Round and green, we have not given any color. Round and green. And this will be small r, wrinkled and yellow. Yes. So wrinkled, small r, capital Y, small y. Wrinkled and yellow. And last one is wrinkled and green. Okay, so wrinkled and green, let me give it. So last one is small r, small y, small y. Wrinkled and green. This one is small y, round and green, round and green. Green and yellow, and green and yellow. Na? This one I should give it blue color. This one small r, capital Y, small y. Right? So here is the result. How many yellow colors are there? So this with this Punnett square, it is the result of F1. Result of F1 generation. So what result we get? How many round and yellow? Let us write here. How many round and yellow?
9.
yellow 9. Let us count it 1, 2, 3, 4, 5, 6, 7, 8, 9. And round and green. Round and green how many? Round and green this one, right? 1, 2, 3. Round and green 3. Now wrinkle and yellow. Wrinkle and yellow how many are there? Wrinkle and yellow, blue with blue color we wrote it. 1, 2, 3. Now wrinkle and green. Wrinkle and green in the ratio of only 1. Means only 1. So finally we get the result of F1 generation 9:3:3:1. So here 9:3:3:1. So 9 round and yellow, 3 round and green, 3 wrinkle and yellow, and last wrinkle and green only 1. So you can see that the least is the wrinkle and green, because wrinkle and green both of them are the recessive trait. So with this also Mendel has expressed his experiment and has said that the characters are discretely, they are discretely segregated. They do not blend. They don't mix, right? Here, for example, round shape did not influence the wrinkle shape, or the color yellow did not influence the green. There were no any intermediate color, or both of them did not express, right? So with this experiment or with this cross, Mendel has shown that the characters are segregated independently, by which he has given his law, that is law of independent assortment. Independent assortment, each of the characters are independently assorted. Independently means without the influence of other, right? Without the influence means out of the pair. Basically, out of the pair means, for example, the contrasting character, round and wrinkle, or yellow and green, they did not influence each other, independently are segregated and they are inherited, right? So you can see here, even if the parents are mixed here, parents are mixed, are heterozygous, but they did not blend, and independently each of the characters are assorted. So with this he has gave the law